What is a limit of a function? Okay? Kanina tingnan lang natin, saan ba natin kailangan yung limit? But then we haven't answered yet. What is a limit of a function? Again, let me be very clear. Kailangan yung tanggalin yung usual notion ninyo. Because in a casual conversation, when you say limit, it is some sort of a boundary. But it's not really the case. Limit is more on behavior of functions. Okay? Kailangan nyo kasing pag-ingatan din sa mathematics, not just in calculus, yung use natin ng mga casual terms like the word limit that we often associate to a boundary. Okay? But then as we will see, hindi naman talaga siya some sort of a boundary. Sabi ko nga, behavior. Thank you. So Mark, Luke, you answered value it gets near to, how a function behaves as it approaches a certain number. And that is really the idea of a limit. The behavior of a function as the values of x approaches some point. Sabi nga rito ni Mark, values it gets near to. You can interpret it as a boundary. Hanggang dito ka lang, but that's not really a boundary. It's more on the behavior. Let me show you. Okay? So this is the notation that you are already familiar. Tama? Okay? We are given here a function y equal to f of x. Function f defined by that equation. And a and l here are real numbers. And I'm sure you already encountered this limit notation. Okay? But what do we mean by this? We'll go to the formal definition in a short while. Okay? Someone asked kaagad, available po ba ang mga slides? Of course, I have to talk to the tech team and then the team. Okay? But then of course they will be made available. Okay? But then the distribution will be via the team. Okay. Can someone probably volunteer? How do you ano ibig sabihin nito, nakita niyo, or probably how do you read this notation? Again, this is a notation. So when you say notation, they are simply symbols that somehow try to summarize a general or a longer idea. Okay. So ano ibig sabihin ng notation natin, or probably a better question is, how do you read this notation? Anyone who wants to volunteer? The limit of a function as x approaches a. Okay, so, yep. The limit of a function as x approaches a, in this case specifically, is L. So again, that is a notation to denote this sentence. So in itself, it is in fact a sentence. It is a sentence that denotes, it is a notation that denotes this sentence. The limit of the function as x approaches a is specifically, that limit is L. So this is a notation. So what do we mean by this notation? Okay, tingnan natin. Let's start with this example. Okay, may nagsabi na rito, tells us the values that a function approaches to as the function's inputs get closer and closer to some number. And yeah, that is what it is. So let me show it to you now. So let's say this one. What is the limit of x squared plus 2x minus 1 as x approaches 0? So ang gusto nating tingnan daw dito is to look at the behavior of the function values x squared plus 2x minus 1 as the values of x tends to 0. How do we do this? Anyone? How do we do this? May nagsabi ka agad dito, L is -1 po ba? Okay. Of course, the question is, how do we arrive at that value? Yeah? The limit of x squared plus 2x minus 1 as x approaches 0 is L equal to -1. But then, why? So may nagsabi dito si Miss Telma. Miss Telma mentioned substitute 0 to x. But of course, the question is, bakit isa substitute? Okay. Substitute daw yung 0 sa x. And really, if you're going to substitute x equal to 0 here, 0 squared plus 0 minus 1, it will give us -1. But then the lingering question is, why substitute? Bakit substitution yung gagamitin natin? Since all values of x approaches 0. So yun yung curious dito, approaches. We are not really saying x is equal to 0, right? We mean x, by this arrow, that the values of x approaches 0. But then the question is, why are we substituting it as if x is equal to 0? Right? We can have direct substitution, yeah, but then of course the question is, why do we have to do that substitution when we are just referring to the behavior of the function? And as you will see, there are some theorems that will take care of that. Yeah, correct po yung mag-substitute ka lamang dito. But then the next question is, bakit substitution pero ang gusto lang natin ay behavior as x approaches to? Di ba? Pag sabi nyo kasi approaches to, we don't mean x is equal to 0. Alright? Lumalapit ka lang sa x equal to 0. So again, the question is, why do we have to go out for substitution? So that is one thing that we're going to answer later. There's an answer for that. But then again, kailangan nyo kaagad i-remove yung notion that when you talk of limit, this is basically substitution. Limit is not substitution. But then, some theorems in limit will tell us that for some functions, we can do substitutions. Okay? So again, limit is not about substitutions. But then there are theorems that will tell us that for some functions, we can do substitutions to get limits. Okay? And those are the limit theorems. We will see them in a short while. So, bakit talaga naging -1? Okay. So one thing that you can do to justify that, tanggalin ko muna si epsilon delta ha. Huwag muna tayo mag-epsilon delta. Gawin natin yun mamaya. You can look at the graph of the function. Diba? Definitely, x squared plus y equal to x squared plus 2x minus 1. The graph of that will be this parabola. I will not go over the details bakit naging parabola yung graph niya, but then definitely it's a quadratic function. You can get its vertex. It will be opening upward. You can even get the x-intercepts. Okay? But then goal kasi natin is at x equal to 0. So when you say x is equal to 0, we are referring to this one, x equal to 0. So we want to look at the behavior of the function as x approaches 0. So what you can do is to trace the graph. Okay, you can probably trace the graph going to x equal to 0. Going to x equal to 0. Tama, di ba? Just simply trace the graph going to x equal to 0. And then also from the other side, trace the graph going to x equal to 0. And really, we're going to see a behavior that the function values will approach the y value here. And the y value here is, of course, -1. Okay? So looking at the behavior of the function based on its graph, we can trace the graph going to x equal to 0 from the right and then from the left. And we will see that really the function values will approach this -1. Okay, so going beyond substitution, you can actually look at its graph and trace the graph to look at its limit. But then, of course, that is a bit, how should I say it? It's a bit too casual, tracing the graph. Ang problem kasi doon, when you draw graphs of functions, there is always that question, how precise is your graph? Diba? Because a graph, when you draw it, is just an approximation of the actual graph of the function. Di ba pag nag-trace kayo ng graph, hindi naman palaging perfect yung pag-graph ninyo ng function unless you are going to use some software. So the problem with that technique is it might be the case that you are drawing a wrong graph or an imprecise graph. There must be something wrong in how you draw it. Napalaki siguro yung buka ng parabola, napaliit. So in essence, in some cases, if you are good in drawing graphs, you can rely on the graph, but you cannot always rely on the graph of the function. I already showed you one example a while ago, yung y equal to sine x over x. It's difficult to graph that function on its own. There are lots of behavior that you might need. So hindi palaging pwede kang mag-rely sa graph ng function. Alternatively, what you can do is to plot some points. Okay? Probably ilan sa inyo naalala na itong activity na ito in high school, in calculus, in college, probably senior high school. Yung ginagawa, we want to look at the behavior of the function as x approaches 0. So the idea is you substitute values of x that goes to 0. So what do we mean goes to 0? You can go to 0 from the left, or you can also go to 0 from the right. That's why, as you can see from the table here, notice, yung nasa left are the values from the left of 0 starting at -1. Starting at -1, which is values of x that makes it nearer and nearer to 0. -1, -0.5, and so on. And also, from the right starting at x equal to 1. Okay? We are not going to do that activity right now that I'm going to actually ask you to perform the computation because, again, we have a limited time for today. But if you're going to perform the substitutions here, this is what you are going to arrive at. Okay? You look at the values of x from the left of 0, and you look at the corresponding function values. -2, -1.75, -1.375, so on and so forth. You look at as x approaches 0 from the left, and you look at the function values. Okay? -1.00019, -1.00001. Okay? There is some behavior. And you can also look at, in a way, the same behavior from the right. From the right of 0. You look at that, the table on the right-hand side, starting with 2, -0.25, and so on and so forth. And you look at that. At 0.0001, the function value is 0.99999, and so on. And of course, you can continuously go to make the values of x nearer and nearer to 0. And as you will see here, we can also observe the same behavior. From the left of 0 and from the right of 0, the function values approaches -1. -0.099999, and so on. Ito naman, -0.00000, -1.0000000, and so on. You cannot deny that there is really some tendency in the function values that are consistent, not this dot, with what we have seen here. That really from the right and from the left, the function values approach -1. Okay? But again, even if you're going to do it graphically, that is requiring some precision in graphing or in substituting values, okay? Meron pa rin, of course, question ng precision and accuracy. Okay? Baka nga pilosopihin kayo ng mga estudyante ninyo, sir, paano pa pag mas marami pa tayong 0.0000001 and so on and so forth? Okay, you can continuously do that, but then of course, wala pa rin mag-justify. You are still relying on some sense of some form of an intuition that really the function values will approach -1. Di ba? Baka naman at some point magte-terminate yung 0.99999. Right? Posible, di ba? Then of course, common notion will tell us that that is not the case. Okay? So now, ito yung problem natin. How can we be more precise rather than simply relying on graphs and function values? Okay? Ito yung example na pinakita ko sa inyo kanina. Okay. Let's say for this one, y equal to sine x over x. Usual trigonometry will not give you the technique in drawing the graph of this. Tama ba? Y equal to sine x over x. Wala. Trigonometry, I doubt. Trigonometry will be enough to give you the graph of this function. The function is undefined at x equal to 0, but then notice there is some behavior. Even if the function is undefined at x equal to 0, you can observe some behavior. You trace the graph from the right, you trace the graph from the left, and notice the function values will approach this one. It's -1 actually. But then notice it's undefined at 0. Okay, so what will justify na talagang siya ay -1? The function is undefined at x equal to 0. What will justify that the limit will be -1? And usual substitution will not work. Because if you're going to substitute x equal to 0 to sine x over x, tama di ba? Sine of 0 is 0, denominator is 0, it will give you a 0 over 0. So definitely, substitution will not always work. Let me go back to what I said a while ago. For limits of functions, substitution will not always work. However, for very special types of functions, you can rely on substitution. So dapat at this point, tinanggal yun na kaagad na pag sinabing limit, substitution kaagad siya. Hindi. For some functions, substitution kaagad, but in a general sense, it's not always substitution. Okay po ba tayo doon? So kina-clarify na kaagad kasi natin yung usual notion na pag nakakita ng limit, substitute ka kaagad. It's not always the case. Okay? Sige. Ito pa yung isang pinakita ko sa inyo kanina. And definitely for this one, it's difficult to look at the behavior of this one. Okay? Yeah. So it means that really we have to go beyond substitution and graphical techniques. There must be some way to give us a more theoretical or a rigorous way of defining a limit of a function.